This video is on the preparation of amines. Amines are a very common functional group in nature and tend to be found in molecules that are biologically active. In fact, most drugs contain amines. Incorporating amines into molecules is not too difficult, as less bulky amines are good nucleophiles, as the nitrogen has a lone pair and whatnot. So these are readily used in SN2 reactions to form substituted amines, i.e. we're making more complex molecules. Unless it's a tertiary amine, we will always have a proton on there, which we can then deprotonate to form neutral amine products. If we're splitting hairs, the product will still contain the proton on the amine, as that amine is going to be basic at the lone pair. So we usually need to add a base to deprotonate to get the final product. So if you're making a neutral amine, make sure to have a second step showing the deprotonation. Now you have a go. What would be the product of these following reactions? You may pause now. And here are the answers. What we have seen so far are efficient ways of making primary amines into secondary amines, secondary amines into tertiary amines, and tertiary amines into quaternary ammonium salts. But we haven't mentioned primary amines. Well, it turns out primary amines are slightly more difficult to make. We need the Gabriel synthesis, which is a very specific method of making amines. Okay, you start with a phthalimide, and you have to deprotonate it with a base to make it nucleophilic, and then you mix it with the alkyl halide of your choice to yield this intermediate product. You then stir it with a strong base and water, and you will get your primary amine on the alkyl halide of your choice in a very high yields. Once again, the final step with the strong base and the water is not your standard SN1, SN2 or E1, E2 reaction. We are just removing the bulk to be left with the primary amine. We'll worry about the mechanism next semester. Luckily for us, it being a named reaction means it also is a consistent mechanism, and the reagents don't vary much. So this should be a relatively easy reaction to spot. For example, what is the product of this reaction here? You may pause now. And yes, we are just replacing the bromide with a primary amine. With inversion of stereochemistry, of course, because the Gabriel synthesis is an SN2 reaction. Let's try a slightly different question. What conditions would you require to make this product? You may pause now. And here is the answer.